Good evening, everyone. I hope that all of you had a good Diwali break or are still having a good Diwali break. Just to introduce myself, my name is Neena Jain, and I'm the Secretary General of United Schools Organization of India. And I must say, this is one of my most exciting activities that we have been doing for a while and are doing even now, simply because it combines what we do for science, how it's done, and the real life applications. So it's a very, very interesting subject. All right, I think someone's echo or mic is on, because of which we are having a little bit of background noise. All right, so without further ado, perhaps we can start. So we are here on the 7th webinar, which is Peeping into the Science of Earthquakes. Very, very interesting and topic that we have here. So just to sort of some housekeeping items before we start our actual presentation. This webinar is being recorded and is being streamed live on USO's YouTube channel. The teachers who are part of the Teams link here, you have received also another YouTube live link for to pass on to your students, and they will be able to view the video and the entire presentation of this webinar on the YouTube channel. So for the sake of the webinar, the mic, video, and chat has been disabled. They will be enabled during the question and answer round. We'll enable and we'll open the chat up again. So any questions that you have can be asked at that stage. So just to sort of give you an overview about the partners who are conducting this webinar series. So to give you a little bit of background information, Science 101 is a series of 12 webinars. It is organized at the end of or the last Friday of every month. And this is to help students understand the real life applications of science. So we have had 6 webinars already. Time truly does fly. It's which means half of the year has already been covered. And this is getting into the second half or the last half of the webinar series. So we are now on webinar 7, and this has been organized by or in collaboration of USO, which is United Schools Organization of India. Just to tell you a little bit about us, we are a registered society. We were established in 1951, and we work with schools nationally. It is our mandate to improve the moral, cultural, and social standards of schools in India to global levels. We organize several extracurricular tests, seminars, conferences, competitions, campaigns, and that too on a national platform, so that awareness about social or global issues can be highlighted amongst the schools. We've been doing this, as I've already mentioned, since 1951, and several issues have hence been highlighted. For this webinar series, we are partnering with CSIR-NIScPR, which is the Council of Scientific and Industrial Research. It was established by the Government of India in September 1942, and it's the largest research and development organization in India. So NISpR was formerly NIScare. It is located in New Delhi and is an information science institute in India founded in 2002. I also have the pleasure of having Mr. C.B. Singh, who is joining us as well. Sir, can I invite you to say some words about...
Yeah, thank you, Ms. Chen, for inviting me. First of all, I express my gratitude to Dr. Sandeep Gupta, a scientist from CSIR-NGRI, who has spared time from his busy schedule and is now interacting or speaking about his domain expertise to the students and to the teachers. And I welcome him. I also welcome the members of the USO, all staff of the USO, my divisional members who have joined here, as well the teachers and the students. So this webinar series is particularly going on under the umbrella of Jigyasa. So Jigyasa is a term which has been coined by the CSIR in 2017 when it has a collaboration with Kendriya Vidyalaya Sangathan schools. And why this was required? Because a trend has been seen that most of the students are moving away from the science and they are opting for the humanities. Does it mean that the lucrative opportunities in science has reduced? So just to come out that why is it happening so, or is it the proper information is not being passed on to their students? They are not being told to them that what are the different opportunities they can find when they opt for the science stream. So this is just an idea that the CSIR thought to have something in 2017, and then a platform called the Jigyasa came up. So a collaboration between Kendriya Vidyalaya Sangathan, then later on this particular collaboration has been extended to Navodaya Vidyalaya Samiti also, and to the other state government schools also, in addition to the KVS. So the CSIR-NISpR Jigyasa division is particularly working as a mediator between the students, teachers, and to the scientist. So a mediator means a middle platform so that they can able to inculcate the scientific temper among the children, to bring in close to the science. And how this can be done, there are the different ways by which this can be achieved. So basically, uh, the first and the foremost which has been thought upon is that let's have a webinar series. So this particular webinar series not only from a particular domain or not from a particular stream, but from the different research areas. That's why we had been approaching to the different scientists working in the different fields. Few the back lectures, what we had seen is that one is from the lavender, the floriculture, how the lavender has been grown. So this way we had been going on then with the road research also, that what kind of research and what kind of a new technology which has come up in the case of the road improvement. So all these kinds of the thing has been happening under the webinar series. There are the other models also by which the students can come up and then can go to the different labs which is pan India of CSIR, that is Council of Scientific and Industrial Research. It has 37 labs spread across India. So the students at their here, like in Delhi, if the students or the teachers would like to come, then they can come to NISpR also. So NISpR, where what kind of work is going on, what kind of a research is going on. There the other labs also, like National Physical Laboratory, how the weight measurement standardization has been done, they can visit there. Similarly with IGIB and the road research, CRRI. So there are the 4 labs here. The students, teachers can make a visit to these research institutes under the umbrella of Jigyasa. So this is one way. One is that like a webinar we are conducting. Other is the visit of the students to the research institutes. Then third is like either the scientists can, instead of virtually, that they can go to the schools where they can deliver their expertise, they can deliver their research work, what they had done, and how it is beneficial. So these kind of the things, the different models also, some like summer vacation programs is also there. The students can come and then can visit the labs and can carry out the summer vacation programs, carry out the experiments under the guidance of the researchers there. So basic experiments they can also do. Similarly, student residential programs is also there. Then the teachers workshop, the teachers can come instead of the students, the teachers can come, and then later on they can go back to their school and then they can express that what they had learned there, and then they can tell the students. So the motivation can be created among the students that okay, science is also a stream or a field which will give a more enrichment to the students. So this is the basic idea of the Jigyasa program under which we are conducting this webinar. Moreover, statistics like what we had done it since 2017, we have interacted with like around 3 lakh students. We have interacted since 2017. Then more than 22,000 teachers has been benefited from the program, the teachers program, when they come to the different labs. Around 165 popular science lectures has been organized, and 1395 programs has been organized, like the different kind of the programs, going to the school, organizing the different activities there. So this is a short summary of the activities that has been carried out and the count that we have expressed to you. So the basic idea is that the students should at least explore to the science. It's not like a basic. There are the many applied fields which has come up in the science. The students come up. They can they can satisfy their inquisitiveness about the different daily activities, how the science is prevalent into them. So this is all about the Jigyasa program and the core concept of this webinar that we are conducting for the students and the teachers also. So this is all from my side. Thank you. Ms. Chan, please continue.
Thank you, Mr. Singh. Thank you very much.
Thank you very much.
So just to go ahead with our webinar series, this is our 7th, as I mentioned earlier. And the topic for this webinar is Peeping into the Science of Earthquakes. And just to let you all know, those who are joining us for the first time, we will have our scientist, a very prominent scientist, talk to us about this. And this time we have decided to incorporate a quiz. And in fact, it's a very exciting quiz. And then we will open the floor up in the chat box. You can type the questions, and the questions will get answered at the end of the webinar. So I have the pleasure and honor to introduce to you Dr. Sandeep Gupta, who will be taking you on to this journey of learning a little bit more about earthquakes than what we knew earlier. He is presently the senior principal scientist. So I'll just take a moment to tell you all about the wonderful work that he has done. He's received his MTech in applied geophysics with University Medal from the University of Roorkee, which is now IIT Roorkee, in 1997, and then went on to pursue his PhD in geophysics from Osmania University in Hyderabad in 2004. His thesis was awarded as the best thesis in geophysics in 2004 by ONGC AEG. He joined CSIR-NGRI as a junior scientist in 2004 and currently holds the position of senior principal scientist as well as professor in AcSIR. So in order to understand the seismotectonics, geodynamics, and mineral exploration in varying tectonic regimes, Dr. Gupta generates seismic images at varying scales by using earthquakes and/or seismic noise as source, and applies different techniques such as the seismic tomography, receiver function, noise correlation. He has more than 44 peer-reviewed scientific papers in the national and international journals and has presented over 40 papers in various conferences. He is also the recipient of the National Geoscience Award in 2014 by the Government of India. As a key researcher, he's worked in India-Australia Strategic Research Fund project for exploring the gold potential in Dharwar Craton. That is very exciting, I think, for all of us to know. I'm sure we'll Google where this is. Dr. Gupta has also visited several countries and guided and co-guided many national and international students for their research work. Dr. Gupta is a technical reviewer to many national and international journals and is the associate editor of the Journal of Indian Geophysical Union. So warm welcome to you, Dr. Gupta, on our in our webinar series. We are really very, very happy that you were able to join us today. And Dr. Gupta?
Yeah, thank you, ma'am. Thank you, Mr.
Yeah, I'll hand over the podium to you now, or the e-podium as we may call it.
Thank you, Ms. Jain and Dr. C.B. Singh, our own CSIR team member. So thank you for your nice introduction. So it is really a pleasure to be a part of this webinar, and thanks for asking me to present my work or to tell about the earthquakes in this webinar. So shall I share my slides?
Absolutely, sir. Please, if you can kindly present your slides.
Are they visible?
Yes, we can see your screen now. Yes.
Okay. So, dear students and teachers, the chief guest of this webinar, and team members of USO India and our own lab, sister lab, CSIR-NIScPR, and Jigyasu friends who are attending this webinar. I am really thankful, and it is my privilege to be before you, and a very good evening and namaskar. So today in this webinar, I am going to talk about the earthquakes, because it is very common word nowadays. So as we heard any earthquake, an image comes into our mind that there is a shaking of the fence, shaking of the building, people are running around, and next day or in the same day, newspaper, news channels, and social media is flooded with the news that so much loss of life, so much loss of human, so much loss of the property, and so on and so forth. So, but what exactly it is, and along with these, we get to know that an earthquake occurred at this place of this magnitude, and this much damage has occurred by that. So, what exactly an earthquake is? An earthquake is nothing but the shaking of the surface of the earth by the sudden release of energy in the earth's interior that also creates the seismic waves. So the earthquakes are of different types, or they are caused by various reasons. Few are natural, few are man-made. So I will take first man-made, because of earthquakes can be generated by the nuclear explosions or any big explosion in the earth. When we come to the natural earthquakes, so they could be of mainly two category. One is tectonic, one is volcanic activity. Tectonic earthquakes are caused by the movement of the tectonic plates. I will come into that. So most of my topic, I will try to explain through tectonic plates movement. And another type of earthquakes are using volcanic activity. So what is volcanic activity? As most of you must be knowing, that volcano comes when the magma rises from the magma chamber, and as it moves, so it disturbs the rock mass and generate the stress, and that releasing of the stress is causing the earthquakes. So before explaining about the tectonic earthquakes, let us start with the solar system. This is an image which most of you are aware, or in fact all of you are aware of, that solar system has sun plus 8 planets. In these 8 planets, Mercury, Venus, Earth, and Mars are close to the sun, and they are known as the terrestrial planets, which are made up of rocks and metals with a hard surface. If you see, among these 4 terrestrial planets, the Earth is the largest one. It has atmosphere and is the only one with extensive region of liquid water. But apart from that, in context with the today's talk, the important point is sorry, this is the only known planet which have plate tectonics. So let me introduce about the plate tectonics, which is the one of the major reason for the earthquake generation. So to understand the plate tectonics, let us see the Earth structure. This most of you are aware of, that this is the Earth. Let us take a slice of the Earth. So if we see the upper hard part of a is known as crust, which has a thickness from 5 to 100 kilometers. Below this, it is a mantle, which is a semi-solid part and made up of molten rocks. Below this, we have outer core, which is liquid, and in the last, towards the center of the Earth is the inner core, which is again a solid part. So now, if we take the upper part of the crust and the uppermost part of the mantle, this is called lithosphere, which usually in general term we call it plates. So most of the time you might have heard about the plates. So this is what the plate means. The upper part, the crust plus uppermost part of the mantle is known as the plate or the lithosphere. So in the we see there are 7 major tectonic plates, which are African plate, Antarctica plate, Eurasian, Pacific, Indo-Australia, North America, and South America. Apart from these, there are a few minor tectonic plates as well. So, so now let us understand. As I told, these plates are the upper part which is floating on the mantle. Mantle is nothing but a molten rocks which keeps on moving because of the mantle convection or Earth's internal heat. So when these plates, as you have seen, when you boil the water, so it moves, and if you put a small or very light material over that, so that also moves. So in the same analogy, you can visualize that how plates moves. So when these plates moves, mostly these plates moves either they slide past each other, or they get separated, or one plate goes beneath another plates. So, but these plates, when they move with the moves, this movement is not so easy. What we think for. So when these plates move, they get resistance from the other plate, and that resistance gives the stress. So these stresses gets built up in that region where these plates are moving. So again, I am giving you one example. As we see in our daily life, our parents, they are engaged in professional, personal, social responsibilities. But over that, if we are not reading or if we are not studying properly, they again get stressed up. So that type of stresses are similarly, the stresses are building up in the Earth. So Earth and everything has a capability of holding the stresses. Like in our life or our parents, they can hold some level of stresses, but after that, they scold us. Or similarly, the Earth also, which is made up of rocks. So rocks have a capacity to hold some stresses, but if the stress level is more, then it bursts up. So, and that creates the earthquake. So this is what the sudden release of the energy from the Earth, which creates the earthquake. So as I told, this map shows the tectonic plates. Here, apart from the major tectonic plates, you can see some minor plates as well. Okay, so here this slide you can visualize that as I told in my previous slide, that earthquakes occur along the boundaries of these plates. So this map shows these are the location of the earthquakes, where you can see that these earthquakes are along the boundary of the earthquake. So
Dr. Sandeep?
Yeah, yes, madam.
Sorry to interrupt. We are not able to see the slide of the map, sir. We're still on the first slide. That's what's being projected.
Oh my God. So shall I share again?
Shall I share from my screen, sir?
Yeah, that would be fine. That would be fine.
Just so I'll share from my screen.
So do I need to start again?
No, sir. We'll go through the slides. It will be valuable for everybody to see. Just give me one moment, sir. Yes. So I think we.
Yeah, I am fifth or sixth slide at this moment. So if you agree, means allow, I can start again.
I think we went through this one already, sir. The crust, the mantle, and the outer core.
Yeah.
And the inner core.
Yeah.
This one, sir?
No. Next.
This one?
I am unable to see it. On my screen, it is not moving.
Yeah. Are you seeing the maps?
Yeah. I think I can.
Yeah. All right, sir.
So this I explained. Yeah, I was here. So this is what I was trying to explain, that if you see both the maps, and there is a that all the earthquakes are occurring close to the plate boundaries, and sometimes inside the boundaries as well. So this is the world scenario. You can see that how the earthquakes are at the convergent plate boundaries. The convergent plate boundaries are nothing where one plate goes beneath another plate. This is the line where the earthquakes are at a point where the divergent plate boundaries. It means where the plates are moving apart from each other. So, and these are the earthquakes which are at the transform plate boundaries. It means that one plate is passing close side of another plate. So this example is from St. Andreas Fault. This example is from the Mid-Atlantic ridges, and this is from the Pacific region. So similarly, in case of India, if we see, this is the earthquake distribution map of India, where you can see that most of the earthquakes are in the Himalaya region, Andaman region, or in the west coast, or in the Gujarat region, Bhuj region. So similarly, this map shows higher magnitude earthquakes from India. So now, since we know that now we understand what are the causes of the earthquakes, now we have to learn more about the earthquakes. So this is one more type. Through this cartoon, I would like to show that how the volcanic earthquakes occur. So after that, once we have an earthquake, we try to, as a seismologist or as an earth scientist, we try to characterize it with the help of type of fault, location of earthquake, magnitude, intensity, and energy release. So these terms you might have heard during the news coverage after the earthquake. So to explain this, let us have a simple cartoon where, because these terms would be required to understand earthquakes properly. This is the point focus, which is the point where the earthquake originates, and the point just above it is known as the epicenter. So these earthquake is generated, and or it can move the faults on movement of the faults. So this is known as the fault trace, and this is known as the fault scarp. And once an earthquake occurs, it generates the seismic waves. So we will be using all these terms in the subsequent slides. So before going further, let me explain you about the type of faulting. So this is a normal fault. Normal fault can you run the this video, please? Okay.
So where is the
yeah,
video?
you just this is a video. You just click on the
This one?
Yeah, normal fault where you have. Or shall I try once from my side?
Yes, sir, please. Yes, sir, please, because I don't see any video link in the slide.
No. If you just click on the norm this arrow where I am putting, it will work. No.
No, sir, it's changing the slide.
Oh. Okay.
If you.
Okay, can you unshare it so that I can share?
Yeah. So please share. If you can share, you can just start to present. You have presenter rights.
Is my slides visible?
Yes, this one is of the maps, sir. The world maps where we have the convergent plate.
Now, characterization of earthquake.
No, not yet, sir.
No.
Yeah, there's a characterization of the earthquake.
No.
Yes, types of faulting.
Yeah. So types of faulting, you can see we have 3 different types of fault in general, although there can be a combination of different types of faults. This is called the normal fault, where you can see one block slides again, one block is sliding down. In this, one block is going up, and in this, you can see that one block is sliding past of another one. So based on these faulting, we characterize the earthquakes. So now again, so as I told that during an earthquake, seismic waves comes up. What is seismic wave? It is nothing but a acoustic energy that travels through the earth. From this cartoon, you can see that as this earthquake occurs at this focus, the seismic waves comes out. These waves travel all through in the earth. So few waves travel inside the earth and few travels along on the surface of the earth. So based on these, we characterize these waves, seismic waves, of 2 main types. One is body wave. Body waves are which travel inside the earth. So they are mostly they are of 2 categories: primary wave and secondary wave. So similarly, surface wave which travel along the surface of the earth, and they are of 2 types again: Rayleigh wave and Love's wave. So I want to show you that how they travel. So this is cartoon shows that in the P wave, which is a body wave, just observe this point, black dot. So as the wave moves, the particle motion is in the direction of the propagation of the wave. Okay. But in case of surface shear wave, as the wave moves in one direction, the particle motion is perpendicular to it. So it can be in the vertical direction as well as in the horizontal direction. But in case of surface wave, which travels along the surface, the particle motion is elliptical. So they roll, and these waves, since they roll and they travel along the surface, this is example of the love wave. Since the surface waves are travels along the surface of the earth, and their movement is in the form of rolls, so they are more destructive waves than the body waves. So we get destruction with the help due to these traveling of these waves. Okay, so now once we know about the seismic waves, now the question comes: how do we record it? How we identify them? That whether there is an earthquake or what happening. So for that we have instruments which is called seismograph, which is usually made up of seismometer plus recorder. Seismometer is the key factor, or in that seismometer works on the principle of a pendulum. So in that you can see that one heavy mass is attached with a spring. So usually it is in standing, it is not moving, but once an earthquake occurs, so it starts moving, this mass moving, and reflect in the paper or recording instrument. Similarly, you can see in this picture, as the waves are coming, so it starts moving. You can see this is P wave, this is S wave. Okay, so now in another, that there is an earthquake at this point, as the body wave moves inside the earth. So we record P, and then as it reaches, you can see here. Similarly, we can record the surface wave, which are in the last, because their velocity is less than the body wave velocity. So once these waves are recorded, we get a seismogram, which is a record of the, like we have a ECG of our heart or our body. So like that, we generate a ECG of the earth with the help of the earthquake or with the help of the recording instrument. So in this, you can see that first P wave comes, then S wave comes, and then surface waves come. So this, with the help of this seismogram, we can generate or we can create the case about the earthquake, where it originated, how big it was. So it is like a agriculture farm house. So with the help of, we do the postmortem of the earth using this seismogram. So I will explain in my another slides. So we use this seismogram. So how to locate an earthquake, because in the newspaper you listen or you read that an earthquake occurred at such and such places. So this is a seismogram of 3 components, where we first locate where is P, where is S wave. So we find out the time difference between arrival of the S wave and the P wave. So wave originate or epicentral distance, epicenter point to the recording station. So with the help of epicenter, suppose there are 3 and with respect to this station, this is a circle for that epicenter distance. So where these 3 circles cut, so we say that probably, and from this place the origin of the earthquake was. So this is how we locate an earthquake. Now we heard about the magnitude of the earthquake or measuring. So we hear that this much magnitude or this intensity or this energy magnitude earthquake was there. So usually we get confused. What is magnitude? What is intensity? So usually in newspaper we see that this intensity earthquake occurred, but intensity is a different term than the magnitude. So magnitude is the only term which tells about what is the amount of the energy released. It is a fixed number which is calculated using mathematical formulation. And to know the magnitude of an earthquake, we usually represent it on the Richter scale. So, but in intensity is measured based on the destruction. So it can vary. Suppose if an earthquake in one part of a city or at one location, if at one location it can produce more destruction, but at more or less same distance it produces less destruction. So it does not mean that the intensity of the earthquake is different at 2 different places. So it does not mean that magnitude is different for that earthquake at 2 different places. So it is the intensity which is varying. So it is mainly based on the observation, and this we represent based on using modified Mercalli intensity scale. So as I told, that Richter magnitude scale is based on the mathematics. Here there is magnitude A. We take the amplitude of the major phases P phase, S phase, or surface phase. And this is the epicentral distance. Epicentral distance, as I told earlier, the distance between the earthquake occurrence and the recording station. So in usually what happens in some newspaper or in some news, we see that magnitude was this one. In another, magnitude is this one. So usually magnitude is same, but few scientists calculate magnitude based on amplitude of P, based on few calculate based on S, and based on surface wave. So the difference in magnitude is mostly because of the what phase they take to calculate the magnitude. So this is the earthquake magnitude scale, which most of you are aware of. This is a Richter scale. On this, we define the amount of energy release or a magnitude of an earthquake. A smaller magnitude earthquake of less than 3 is very small. It cannot produce much destruction. So like that, we to classify it at the magnitude range of 2, 3, 4, 5, 6, 7, 8. So if we see in Himalaya or that region, we get almost 5-6 earthquakes are of this category. So that's why we usually put more focus on the Himalaya. Similarly, on the Andaman region. Okay. So and as I told, this is the intensity scale, which is based on the observation. So if there is a less destruction, intensity is less. But if it is more destruction of buildings or human property, so the intensity of the earthquake was more in that. You can see here, if less intensity, this building is more or less same before an earthquake or after an earthquake. But if the intensity is increasing, you can see here small damage in this point. So, but if intensity is more, because hello.
Sir, I think you got logged off there for a minute.
Yeah. Now is it visible?
Yeah, we can see the slide which says energy on top.
Okay.
With the log E equals 5.24 plus. Yeah. Okay, sir. All right.
Thank you, ma'am, for confirmation.
Yeah. Sure, sir. Sure.
So energy is again a mathematical measurement. So which is based on the magnitude of the earthquake, because we know magnitude is derived from the using mathematics. So we calculate the amount of energy release. So if we see, by changing the magnitude of an earthquake, the energy differs by a factor of 28. So suppose if we take if there is an earthquake of magnitude 5, so it produces energy amount X. So but if the earthquake is of magnitude 6, so the energy release will be 28 times of X. So 28X. So this is how the energy is calculated. And in a rule of thumb is that 1 7 magnitude earthquake can release energy equivalent to energy released by 750 or 760 to 1,000 number of magnitude 5 earthquakes. So this is what the energy is. Here it reminds me that once I was interacting with the students in a remote area of Pithoragarh. So there one student asked, sir, when earthquake can release so much energy, can we use this energy? So my answer was that it is very difficult to store this energy because we don't know where the earthquake is going to happen. and when it is going to happen. So it is not practical to make some arrangement to store that energy. So this is how we get the curiosity from the students when they listen, talk on such topics. So now I told you that what are earthquakes, how they occur, okay, how we measure, how we characterize it. These earthquakes using type of faulting or measurement through magnitude, intensity, location of an earthquake. So overall, this comes under the under a job of a seismologist, which is a earth scientist. So the seismologists study the earthquakes, how they generate. They also use these earthquakes waves to infer information about the earth's structure, like we do in medical sciences. So earth seismologists are mostly earth scientists and with a specialization in geophysics. From this, as I explained earlier, that this is our starting point. This seismogram is our starting point, where we first identify different type of waves, P wave, S wave, surface wave, or any other phase we have. So we use these phases to locate them and get a map of that area. So with the help of that, we identify which zones are producing more earthquakes. Now, recently, in recent past, you might have heard that most of the earthquakes are coming in Palghar region in Maharashtra, Western Maharashtra. So for that, we put the instruments, we put instruments and we analyze these seismograms, and based on that, we could identify that in particular area, we are getting more earthquakes. So then it comes to the second level, why these earthquakes are coming. Okay, so for that, we generate images. So this is how an earthquake, it generates seismic waves. These waves travels inside the earth. And you can see in this map that how these waves are crisscrossing from this area. And then we generate such type of image. This study is from the Himalaya region, where we characterize how these earthquakes in Chamoli in 1999 occurred, why it occurred in that area. So because
so the slide,
yeah, hello,
yeah, sorry, so the slide is that of energy, the one that has a title of energy.
Okay, still not moving.
No, sir.
Now moving.
No, sir, it still shows energy. Yes, now it's showing the seismic tomography.
Yeah, can I use in a, yeah, can I use in a in this mode so that
sure, sir.
Yeah. Okay, so with this slide, I was trying to explain that why a seismologist or what is the job of a seismologist, or why we study earthquake. So to study an earthquake, and it is a job of seismologists, which are earth scientists. So a seismologist study earthquake about how these earthquakes are occurring, where they are occurring, or what is their characterization, how big, how small, and so on. And apart from that, earthquake genesis, seismologists also study about how a seismologist can do the gold exploration. So similarly, there are how we know about the structure of the earth. So this is how the seismologists come into picture, because with the help of instruments, they generate the seismograms, they identify different waves, different phases, and they analyze it. And these waves, these phases, first they use to characterize from where the earthquakes are coming, or what is the magnitude of the those earthquakes, and by that they characterize the region which are producing more earthquakes. So similarly, this is one part. And in second part, they use these waves, they use these records to these records Here you can see that how the seismic waves are coming, and when there is abnormality in the earth, they pass through that, and with the help of some mathematics or some techniques which are most of seismologists are working on, they generate the image of the earth. So because of the seismology, earth scientists could find that the inner core is solid and outer core is liquid. So this is the advantage of working or studying the earthquakes. So with the help of study of the earthquakes, you can not only identify the zone of future earthquakes or the zone where the earthquake occurred, but at the same time you can identify what is the structure or what is the physiology of the earth, like our medical doctors does. So this is what from my side, and I am extremely sorry that the slides could not move properly. So there was so much interruption in between. So if you have any question, any doubt, you can ask in the end of the talk, as well as you can email me on this email. So now this is time for some quiz. Okay, so are the students ready? Hello.
Yes, I think, and we have also opened up the chat box so that the questions can be typed in the chat. So teachers are on. Yes, sorry, sir.
Yeah, it's okay. I would request that all the students should attempt these questions. They are very, very simple questions, and they can answer it and they can submit to their respective teachers. So, or in case if there is unclear question, they can, or they want answer for any question, they can write into the chat box. I can answer in the last. So my first question is, in which part of India we get more number of earthquakes? Himalaya, Central India, West Coast, South Indian Shield. So, ma'am, can you help me?
Yeah. So just give me 1 minute. I seem to have gone into a different screen, but I think somebody did mention. Yes. So we have already started to get responses. We've got 3 responses, Himalaya.
Wonderful. It is the correct answer. So because it is a convergent plate boundary, so in India we get more of earthquakes in Himalaya. So now, second question is, which instrument is used to record an earthquake? Speedometer, seismograph, thermometer, none of these.
Okay. We've got a response from Mr. Shivansh, seismograph. And Miss Lata also has said option B, which is the seismograph. More answers are also coming with the option of B. Miss Prachi has also said it's B.
Yeah. So it is a correct answer. So now, third question is, the wave caused by an earthquake can travel through Earth's interior are known as seismic waves, tidal waves, sound wave, X-rays.
Okay, Miss Lata says option A.
Yeah. It is
Mr. Karthik also says option A. Mr. Ravi says seismic waves. Mr. Abhinav says option A. And another gentleman, I think, says A. All the answers that are coming are A, sir.
Yeah, it is perfectly all right. So this is the correct answer. So now coming to the next question. To locate epicenter of an earthquake, what is the minimum number of seismographs needed? 2, 3, 4, 5.
So Mr. Ravi says 3.
Yeah, it is correct answer. So as I explained in my slide where I showed how to locate an earthquake. So to have a proper interaction, because if we have 2, so there are 2 points where the 2 circles will cut. So it is very difficult to point out which point is the location of the earthquake. So that's why, to make it narrow, we use one more. So if we add more, that is fine. So now coming to the fifth question. Tsunami is powerful ocean wave, which is triggered by storm, wind, earthquakes under the seafloor, all of these.
So we have started to get responses, sir. A lot of C's, C, 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 C.
Yeah.
Everybody is writing. Yeah.
Yeah, it is a correct answer. How? Because tsunamis are generated in the ocean. So they are generated with the when the seafloor moves or that part moves. So that is possible with an earthquake or a volcanic activity inside the ocean. So storm is not in the earth, or similarly wind is not in the inside the earth. So C answer is correct. Can we record earthquakes on moon? Tricky question.
Indeed. The answers that are coming from Mr. Shivansh is yes. Mr. Karthik also says yes. Mr. Ravi for question 6 says C, which is sometimes. Mr. Abhinav says yes. C, and Ms. Mehak says yes.
Okay. So if all have answered, then I should answer it. It is no. Because it is earthquake is a phenomena related to Earth. So if any quake occurs on moon, it is known as moonquake. And these moonquakes are not because of plate tectonics, or they are mostly because of the meteoritic impact on the moon. So we cannot record earthquakes on moon, because whatever activity or whatever quakes are there, they are known as moonquakes. Okay.
That was a trick question, but a very interesting question, no doubt.
The most powerful earthquake ever took place in the world. Sorry, it is mistake in Japan.
Shivansh says Japan.
Okay.
Also, Mr. Ravi says Japan.
Okay.
Japan as well from Mr. Karthik.
Okay.
Also another response A. Ms. Mehak says Japan. Mr. Abhinav says Japan.
Yeah, I think to some extent they are right, because they did not, because they are aware of the 2011 earthquake of Tohoku. So that's why they are thinking. But it is, the answer is Chile. So we had a 9.5 magnitude earthquake in Chile in 1960. So the most powerful earthquakes so far is in Chile. Okay, the answer is C. Now we are moving to the next question. The magnitude of an earthquake is duration of a quake, length of a quake, destruction caused by an earthquake, amount of energy released by an earthquake.
So Mr. Ravi says C.
Okay.
Mr. Abhinav says 4. We have another response, which is B. Mr. Shivansh says B. Mr. Karthik says C.
Yeah. So whoever said D, it is a correct answer, because as I explained in my slides, that there is a difference between magnitude and intensity. So duration of earthquake is nowhere related with magnitude, and similarly on the length of the quake. And about destruction caused by an earthquake is, we measure based on the, we use a parameter called intensity. Okay, so the magnitude represents the amount of energy released. So magnitude is a mathematical we use mathematical formula to calculate magnitude. So magnitude is related with the amount of the energy released by an earthquake. So now we are moving to next. The epicenter is point inside the earth where earthquake begin, point on the earth's surface directly above earthquake center. Both of these, none of these.
So the answers that are coming up are A, also A.
There is A is not a correct answer, because point inside the earth where earthquake begins is known as focus or hypocenter. But the point on the earth's surface directly above earth's surface is known as epicenter. So we should know what is the difference between epicenter and focus. So for A, the term we use is called the focus in general languages. Okay, so epicenter is the point just above the beginning of the earthquake point. So now coming to question number 10, the body waves or seismic waves travel along the waves which travel inside the body of the earth, interior of the earth is along the surface of the earth, interior of the earth, both A and B, none of these. How we define body waves? The waves.
So we are having an assortment.
Yes.
Yes, there is a combination of responses of A, C, and B.
I think B is the correct answer. As I explained in my presentation, body waves are the waves which travel inside interior of the earth. The waves which travel along the surface, they are known as surface waves. Okay, so the correct answer is for the body waves which travels in interior of the earth. Now coming to the next, earthquakes in Himalaya are related with convergent plate boundaries, divergent plate boundaries, transform plates, or none of these. I think I have answered this when I was explaining my first question, if anybody remember.
So A.
Yeah, A is the correct answer. Yeah. So as you know that Himalaya formed by the conversion of the Indian plate, or with the interaction of the or under thrusting of the Indian plate with the Eurasian plate. So there we have a convergent convergent plate boundary. So where Indian plate is going below Eurasian plate. So the earthquakes in Himalayas related with the convergent plate. So now next question is, the uppermost layer of the earth is known as crust, mantle, outer core, inner core. Very simple answer question.
So we have got from Mr. Shivansh has said crust. Mr. Karthik says option A. Mr. Abhinav says option A.
I would listen who are not giving answer A. Other than A, anyone?
No, I think.
Yeah, so A is the correct answer. I will go with majority. So now question 13. In general, the most destructive earthquake waves are P wave, S wave, surface waves, none of these. I gave some hint during my presentation about this. And when I was explaining what are seismic waves.
So we are getting a few answers. Mr. Karthik says C. Ms. Mehak says C. Mr. Abhinav says C.
Yeah, C is the correct answer. As I explained during presentation, that the surface waves are the waves which travel along the surface of the earth. They move very slowly and they move in the ground rolls. So they are more destructive than P and S waves. So we move to the next question, which is related with the artificial earthquakes. Artificial means which are not natural earthquakes. So plate movement, volcanic eruption, nuclear bomb explosion, meteoritic impact.
Mr. Shivansh says nuclear bomb explosion. Mr. Karthik says C. Also CC are the responses that are coming up.
Yeah, so it is a correct answer. So here I would like to explain that apart from nuclear explosions, now in the petroleum exploration, when the petroleum is not coming up, we've infused or we've water. So if water is more, so that can also trigger an earthquake. So that is also a sort of artificial earthquake. And even many times rains can also generate earthquakes. So now coming to the next and last question. The scientist studies the earthquakes is known as astrophysicist, archaeologist, microbiologist, seismologist.
So we are having a combination of C, A, D, C, C, A.
Oh, it is
D.
Yeah. Actually, it is not a face to face. Otherwise, I could have asked why A and C, because as you know, astrophysicists are the scientists who works about the planets and other things. Microbiologists are related with biology. So as in that whole talk, it was about the seismics, and even in the last part of my talk, I explained what is the job of seismologist. So the correct answer is seismologist. So anyway, it was a very good interaction. So in fact, I would be very interested to know how many of you would be like to be future seismologist or earth scientists. So thank you one and all. Yeah, now it is a question time.
So if anybody has questions, please feel free to type them in the chat box. I think through the quiz, a lot of these questions got answered, sir.
Yeah. So apart from that, if they have any special question or as well, they can write to you or their teachers.
Absolutely. Any questions that the students may have, the teachers can pass it to us and we'll be happy to share those with you. Okay, so I think there aren't any more questions. So just to inform everyone that our next webinar will take place on the last Friday of November, which is the 25th of November, once again at 4:30, and we shall share details later on. So on behalf of, sorry, sir, just one question has been typed in the chat box. May I please ask the question? Dr. Sandeep?
Yeah, please.
So the question is, earthquake scale is dependent on what condition?
Earthquake scale. See, there are two scales which I explained. One is magnitude scale, one is a intensity scale. So magnitude scale is based on the mathematics where we make use of the arrival of different phases. We take amplitude of different phases, how big or how what was the amplitude of different phase. But intensity scale, which is totally based on the observation. So as I explained, if an earthquake put more destruction in one area, less destruction in another area. So for that particular earthquake, which releases the same energy, the intensity for that region A will be different, but for region B, it will be different. However, the magnitude will be same for region A and region B. So is this the answer you want or something else?
Mr. Shivansh, can you kindly type in the chat box if your question was answered? Yeah, he says thank you, sir.
Okay, welcome.
So I'm assuming there are no more questions. Right. So on behalf of USO, Dr. Sandeep, thank you so very much for taking the time and joining us, sharing your knowledge on earthquakes. I think the one word that constantly came up was the seismic activity and so on and so forth. So I think one of those words will truly resonate with all. But thank you once again for taking the time, explaining it to all the students and the teachers in a manner which is easy for everyone to understand, and for showing how science is really everywhere, and all around us. I'd also like to thank the teachers and the students who are joining us online. Given that it's the holiday week, taking time off for the webinar, which is educative, is